Okay, today we're going to look at 3.1, solving systems of equations by graphing. So what we're talking about is a system of equations is a set of two or more equations with the same unknowns. And to solve that, we will find values for the unknowns, x and y in this case, that satisfy all equations. So you're looking for values for those unknowns that work in all the equations, that when you plug those in, all the equations are true. So we're going to look at solving these by graphing. So we have this example, and we have this system of equations in example 1. So we will just graph both of these, and then we'll see where they intersect. The place where they intersect is the place where both equations are satisfied. And that value, that 1 point, okay, where those lines intersect, that is the point where that particular value for x and y, that ordered pair, will satisfy both equations because it's on both lines where it intersects. So let's look at that. We'll graph this first line. Okay, these are both in slope-intercept form, so we can use that to graph them fairly quickly. The intercept of the first one is -2, the y-intercept, so we can make that point. That's 1 point on that line. Okay, and then we have a slope of -5. Okay, because that's the coefficient of x. Remember, this is y equals mx plus b. M is the slope. So it's -5. So from this point, we can do rise over run of -5. So we'll go down 5. 1, 2, 3, 4, 5. So we did a negative run of 5. So we'll do a we did a negative rise of 5. So we'll do a positive run. Okay? Because one of them needs to be negative and one of them needs to be positive, since the slope itself is negative. Okay? If the slope is positive, we would have both of them positive or both negative. Since the slope is negative, it requires either the rise or the run we'll use as negative, and the other one is positive. So we have this, we have that both points now, and we are going to draw a straight line. And to try to help me do that, I'm going to use this handy like ruler tool. See if I can do this. Okay, let's see. Put that about right there. And this will not work perfectly, but we'll see how well it does. So we have that line. Okay? And now we'll graph the other line. So it has a y-intercept of 2. It has a slope of -1. Right? -1 is m in this equation. That's what is multiplied by x. So again, we can use the rise as -1. Rise over run equals -1 over 1. Okay? So the rise will be going down 1. The run will go in the positive direction over 1. Okay, and we'll get our ruler out again. Something like that. Draw that line. You could also plot points by plugging in values for x and finding the value of y. So we have both lines drawn, and we're looking at this intersection, and that point looks like it's right there. Now, that should be our solution. That point is the x and y that make both equations true. And this doesn't work perfectly, but the whole number that's closest to is negative 1, 3. The reason it's not perfect is just the inaccuracy of how I'm drawing them. But this point looks like, if we assume the answer is a whole number, negative 1, 3. So we are limited by the accuracy of the graphing. So that's the solution. And so I'll write that down here. We can check that by plugging it into both equations. So let's do that. We have y equals, and we're going to put in negative 1 for x in the first equation. Okay, just putting it in. So I'm going to evaluate that. Negative 5 times negative 1 is 5 minus 2, and that equals 3. So when we put in a negative 1 for x, we got 3 for y. So the point negative 1, 3 satisfies that equation. Okay? So we want to make sure it satisfies the other one. So let's do that. Y equals negative x. We're plugging in negative 1 for x. See what we get. Negative of negative 1 is 1 plus 2, and that's 3. So in the other equation also, when we put in that negative 1, we got 3. Okay, so the value the point negative 1, 3 also satisfies that one. So that's the point that makes, that's the ordered pair, the x and y value that makes both equations true. We just verified that by plugging those numbers in. And sure enough, they worked. Okay, so let's do one more. Solve the system by graphing. Okay, so just a couple more equations to graph. And the first one has a y-intercept of 1. So we'll draw that in. Has a slope of 4, positive 4. So rise over run, they're both positive. 1, 2, 3, 4 is our rise. Our run is 1. That gives us a point. We have 2 points now, and we will draw the line. I've tried to draw straight lines without using that ruler tool, and it doesn't work very well. Okay, so that's that one. Now let's draw the other line. It's y equals x minus 2. The y-intercept is negative 2. So that's right there. Now we will use the slope to get another point. The slope is 1 because the coefficient of x is 1. We could rewrite this, of course, y equals 1x minus 2. And I'll go ahead and write down the slope-intercept form over here just to remind us. Okay, m is the slope, so that is 1, positive 1. So from the y-intercept, we do rise over run is 1 over 1. So positive, both are positive. The rise is positive 1, goes up to here. The run is also positive 1, goes to here. Okay, now we'll draw that one. About right there. and we see our point. Looks like right here. This one actually looks a little closer to those whole numbers that we hope that it is. So that point is -1, -3, right? -1, -3. Okay. Let's check that. This time I'll actually put in both values into the equation rather than just calculate what y would end up. That's what I did with the other one. I put in x and calculated y and found that y is what we thought it should be. But we could also just put them both in there and make sure it's true. Okay, and that might be a little bit more logical way that you can understand what we're doing. So we say that -1 for x and -3 for y should make both of these equations true. So let's put them in to the first one. I'll write it over here. Y equals 4x plus 1. So we're saying y is -3, and we take 4, and with x is -1, this should be true, right? So -3 equals -4 plus 1. -3 equals -3. It is true. So the point makes that one true. And we'll look at the other one. It's y equals x minus 2. Because this is the point where both lines intersect, again, this value, this ordered pair, should make both equations true. We'll check the other one. We'll put in a -3 for the y. We'll put in -1 for the x. And that says -3 on the left. -1 minus 2, yep, that is -3. Okay, so that makes the equation true as well. So that's a couple of examples. The homework assignment is on Canvas. You'll just have some of these to do yourself. It helps to have graph paper. If you don't have graph paper, you can still do them. Just remember, it's not going to be exact, but just for the sake of the assignments, figure that, yeah, it's probably supposed to be a whole number, and just choose the nearest whole number for x and y when you have that point of intersection. Okay, so that is all for now.